for the next part. So basically you got a common denominator. And now I am solving for R. This is the thing I'm solving for. Yeah. So I factored it out and now I'm going to divide. So this is the expression. And it said, oh, one resistor had 2.3. So this doesn't look like what I did yesterday. Let me do what I did yesterday. So one of them has a resistance of 2.3 and the other one is X. So 1 over R equals 1 over 2.3 plus 1 over X. So I made my common denominator. And ended up with 2.3x equals Rx plus 2.3R. Factored out the R and divided. So this is what I had yesterday in terms of the numbers that you handed out. Okay? This is the total resistance, and it says find the resistance of the second resistor. So find X if R is 1.7. So I'm going to find X if R is 1.7. So this is the equation we came up with yesterday. Now they're telling me that R is 1.7. So I think we can do that. We're going to multiply by that denominator. Get my x's on the same side. And divide. So it looks like it is about 6.517. If I did my arithmetic correctly. So yesterday we got a common denominator and then solve for R. And then today, we're putting in 1.7 for R and then having to solve that equation. Does that look okay? All right, with everybody? All right, one more, and then we'll be done with 2.7. Consider all of the rectangles with an area of 182. So here is a rectangle, and the area is 182. Let X be the length of one side. Express the perimeter. Thoughts? No thoughts?
Wait, 182 divided by 4? Or no, 182 divided by 2. Oh, I did it. 182 divided by 2? And then you...
And then,
Okay, now 182 is the area. So let's suppose I told you the area of this rectangle was 24, and this side was 4. How would you find the other side?
Divide it. So we do 182 divided by
182 divided
x.
by x, yep. Because what happens when you multiply length times width? What do you get when you multiply x times 182 over x? 182? Yeah. So your perimeter is 2 x's plus 2 of those. So 2 x's plus, what's 182 times 2? 364 over x. There's your perimeter. Okay, everybody keeping up with that? Find the dimensions of the rectangle that has the least perimeter. What is the least perimeter? Let's get our calculators out. And let's draw, graph this equation right here. Let's graph that. Let's see what kind of luck you have drawing that.
Just draw your
This is for, why are we using our calculator? Well, the only thing that we can find a minimum of by hand is a parabola that with a vertex. This is not the equation of a parabola. So therefore, to find the minimum, I'm going to need to do it on my calculator. Has anybody gotten a shape yet that has a minimum? Erica, you got a shape that has a minimum? Tell us how you set your window.
My window?
Yeah, just because they don't have it, so they need to have it with your setup. So what did you get for X-min and X-max?
Negative 50, then 200,
Okay,
and then I did negative 200, and then 200.
the 200? Now, there is nothing special about those numbers. I don't know whether they were already in there, if she randomly played around with it a little bit, but try those numbers and see if you get a shape with a minimum point.
Ooh.
Did you get a good shape? Where you can see a minimum? Alright, I'll show you what I use. Again, there's nothing special about these numbers. What do you have to do? You have to find a window where you can see a low point. That's your job. I gotta find the minimum. I used zeros for my X and Y minimums because I thought about my problem. Doesn't X represent a side of the rectangle? So it makes sense that would be positive. Now, her numbers are fine. To get a starting point, that's where I started. I said, well, X and Y have to be positive. And then I actually used just 100. And I got a very defined minimum. So I will second trace minimum. Set my left bound and my right bound. And I got for my minimum point, I got 13.491, comma, 53.963. And the question was, find the dimensions of the rectangle that has the least perimeter. So what are the dimensions of this thing? X and 182 over X? So here's X, and then I need to do 182 divided by that. Oh my gosh. If this one was 13.491, what did you get for this one? With the round off, accounted for. So what is the shape? A square. Yep, a square is gonna have the minimum area, and then, or minimum perimeter, minimum perimeter. And what is the perimeter? 53.963. So this is your perimeter, this is your X. Perfect. Anybody have a question about that? All right, 2.7 done, due on Thursday. And now we're gonna forge ahead into 2.8. All right. Here's our thing, and we have to determine where it's positive, 0, and negative. Any ideas on how we might do this? Without a calculator? Well, let's think about kind of what we were doing earlier in this chapter. I have an x-intercept at -3. Now be careful, that is not 1. That, I can't graph that. So the only other one I can graph is this one. Okay, that's kind of a wild card thrown in there. What's the degree of my polynomial? How many x's do I have all together?
4.
Watch it. 1, 2, 3, 4, 5.
Oh, yeah,
And 5 is an odd number. Odds should start down here. Would you agree with that? Now, what happens when I hit that -3? I'm gonna go right through it. That guy is gonna make me squiggle around a little bit. It doesn't really matter. I've got some kind of squiggly going on. And then I come down and hit this. And that bounces off and heads up into space. Now, where does the function equal 0? That is at -3 and 4. x equals -3, x equals 4. That's where we equal 0. Now, where are we positive? Positive means above the x-axis. So where are we positive? From -3 to 4, but be careful, this breaks it up. So we have to say we're going to be positive from -3 to 4, and then from 4 to infinity. Remember, at 4, it equals 0, so it isn't positive or negative, it equals 0. And then where is it negative? From negative infinity to -3. Now, guys, can we do the same exact thing for the next problem? We can. The only difference is, we don't want to know positive, negative, and 0. We just want to know negative, less than 0. So what does this look like? Have an intercept at -7, an intercept at -4, and an intercept at 6. Are you following? How many x's do we have altogether? 4, which is even, which starts up here. And what does it do when it hits that -7? Goes through and connects. And then what does it do at -4? Goes through and connects. And what does it do at 6? Bounces off. Now, the problem says we want to be less than or equal to 0. That means under the x-axis. This is where we're less than 0. So it looks like the only place that we're less than 0 is from -7 to -4. And I'm using brackets because I can be equal to. Be careful. We also have an equal to at 6, don't we? So these are all equal to's. They all count, and then that part is less than. So this would be the answer to the question. If this hadn't been there, then I wouldn't include that. But since it is, I'm going to include it. All right, you and your partner try number 3. Number 3 is the same thing, except what are you going to have to do first? Factor it. Yep. So go ahead, see if you can remember how to factor it. Michael, you gonna get it factored?
Yes, I am.
Or are you just gonna make do the whole thing?
I'll probably need to do some.
Okay, that's good way to do it. Good way. Please tell me you're factoring by grouping.
Yeah.
Yeah.
Yes. You know, it's just
those three ratios.
No, like, I'm one of four. One is bigger.
How did your factoring look? Did your factoring look like mine? Anybody have a question about the factoring, the grouping? So I put dots at 4, -1, and 1. Nothing squared, no bouncing, nice little cube. And then I want to be bigger than 0. So I want to be this bump right here and this arrow right here. So my answer is -1 to 1, parentheses, or 4 to infinity. How many groups got that? Good, good. Anybody who didn't get that have a question about it? All right, let's go to number 4. This looks like exactly the same problem, except what? Can't factor by grouping. So boys and girls, what do we do when we know we have to factor and we can't factor by grouping? We're gonna guess and divide. And there are a lot of PRRs because 24 has a lot of factors. So certainly you're going to do 1 and 2 and 3, -1, -2, -3, 4. I mean, I don't know. What do you want to try? Let's try 2. I don't know. You might, okay, that was not a good choice. You might, let's try -2. Might have a variable for guessing, I'm just guessing.
Oh, it's 4.
Oh, is it?
Yep.
Oh, actually, it's -2 also. Yeah. So one of my factors is x plus 2. And then I'm going to factor this, and you gave me a hint. You said one of them was 4. So that must be it. Right there, let's see, is that right? And I want to be bigger than 0. So I got a dot at -2, 3 halves, and 4. I'm going to be positive again. This is exactly like the last problem. So -2 to 3 halves, 4 to infinity. All right, I feel like I went through that kind of fast, so let's back up a minute. Everybody understand you're gonna have to divide, guess and divide? So I guess -2, somebody else guess 4, doesn't matter, guess something that works. Factor what's left, and then here are your factors. No matter what you guessed, these are gonna be your factors. So I plotted my zeros, sketched my curve, and once again, I want to be positive. That's it. All right, let's solve the next one on our calculator. Anybody have an idea? There's 2 different ideas. 2 different ideas here for this problem. What's your idea? What are you gonna do on your calculator? Well, could I graph these as two separate equations? Could this be like y1 and this be y2? And those of you that have the calculators with the color, this is gonna be real easy for you, because if this is red and this is blue, then you are gonna be looking for where the red curve is below the blue curve. So that would be one strategy. You want this guy to be lower than this guy. Another strategy would be to move everything over on one side, so add the 8x, subtract the 2. Graph this, it's gonna look something like that. I mean, I'll have that kind of shape. And you wanna know where it's under the x-axis. So either way is fine, whatever works for you. Whatever you think you're gonna be able to best manage. And remember, your window is all boogered up from the last problem we did. So you might want to zoom 6, that's zoom standard, and then adjust from there. That's up to you, but I chose the second option. I put this in my calculator and got this picture, and then I'm finding my zeros. And now I want to know where I'm less than 0. So that would be this part and this part. So my answer is 0.325. Negative infinity to 0.325, or 1.461 to 4.214. So I chose this option. I did it with one equation, sketched that on my calculator, used my second calc 0 button and found these zeros. And then I wanted to be less than. Did anybody do it this way?
I tried, but like I was confused after I saw like this, and then I was confused on what to do after that.
Well, let me draw what you have, and then we'll talk about what you do. So he drew, we're gonna have to open that up a little bit. Okay, first of all, you gotta type in the right equation. Yeah. So we need x cubed minus 6x squared. definitely harder to see with this option.
Wait, I just had my. You're in a hole you can't get out. What? Not mine.
Okay, so playing around with his window, he did this. And the blue curve, they literally are blue and red. The blue curve looks like this. And then the red curve came down like this. So this was the blue curve, and we wanted it to be underneath. So the blue one is underneath from here to here. All this is underneath. And then it's underneath from here to here. So you would use your intersect button and find those 3 points of intersection. And dollars to donuts, that first point of intersection is gonna be 0.325. And then you're gonna get the other two. And then it's between these two and before that one. So yeah, that was, for me, it was really easy to see that picture. For him, it was a little more complicated. We had to play around with the window, but after doing that, we got what we needed to see. All right. All right, number 6, another calculator problem. And again, you need to pay attention to your window. If you don't see what you think you need to see, you need to change it. So let's type in our equations.
Why is it written down?
Why what? Did anybody graph the first one in number 6?
Yeah.
What did it look like?
Parabola above.
Yeah, a parabola above the x-axis. So it looked like this. And we want to know where it's positive. Everywhere. So the answer to the first one in number 6 is all real numbers. Because when we graphed it on our calculator, that's what we got. Where is it above my arm? Everywhere. Everywhere. How about the second one? Well, you don't even need to graph it. The second one is the same equation. If that's what it looks like, where is it negative?
Nowhere.
Nowhere. So this is the answer to A, and the answer to B is nowhere. It's never negative. It's never below the x-axis. All right, you good on that? We have one more problem. Probably aren't gonna get it done.
Yes, we are. Sine 5 minus 3 whole square plus x minus 2x minus 30, and then 4x minus 12, and then squared.
Okay, wait, Eli, what are you doing? What did you do?
Solve it?
What did you do?
Times x minus 3 by both sides.
Okay, stop right there. Stop right there. What do I know about x minus 3?
Can't be 3.
It can't be 3, but could it be a number bigger than 3? Could x be a number bigger than 3?
Yeah.
And if it were a number bigger than 3, this would be positive, and I could multiply it over and life would be fine. But what if it's a number like 2?
It's negative.
And what happens, Jimmy, when I multiply by a negative? That has to change. So here's the deal, Eli, when you multiply in an inequality, you gotta know whether you're multiplying by a positive or a negative. So guess what? Can't do that. Here's what we do instead. We subtract that 4 over. We cannot multiply by x minus 3, but we can subtract 4. Now I'm going to get a common denominator, and I'm going to run out of time. So we'll pick up here tomorrow. I need you to get gathered up and get ready to pray.
What's after? The prayer?
They'll come on in a second. They always do.
When would we do it? Oh, okay, I'm going.
Yeah, I would grab it on my calculator.
Oh, we're not gonna pray, okay?